In this introduction PowerPoint, we will cover the following topics. 1. SQL Tuning Startup. 2. Understanding subqueries and performance issues. 3. Understanding scalar subquery and its characteristics. 4. Understanding the basic concepts of with clause. 1. In the SQL Tuning Startup chapter, it explains how to understand the execution plan and the join method. 2. The Understanding Subqueries and Performance Issues chapter consists of understanding the basic concepts of subquery, SQL performance improvement by using subqueries. 3. The Understanding Scalar Subquery and its Characteristics chapter consists of understanding the characteristics of scalar subquery, understanding and using scalar subquery and join. 4. The Understanding the Basic Concepts of With Clause chapter introduces the performance improvement methods by using the with clause. In this introductory PowerPoint video, we will briefly introduce the tuning method by using subqueries. We will introduce the basic concepts of subquery and its operation method and tuning methods using the subquery. Subquery is a query within a query. It is used as a comparative condition in the where clause. Generally, when writing a SQL statement, the sequential method in which the main SQL output is formed and the values are compared by using subqueries are easier than joining all the tables. However, you must be very cautious as to not overly abuse the subquery, for it might lead to a serious performance issues in the DB server. Subquery uses two major patterns. Like pattern 1, the subquery returns only single row. If the subquery returns two or more rows, then it will generate an error. The main SQL is processed with the values returned by the subquery to complete its search conditions. In pattern 2, exist or in are used, and it can return multiple rows. It can be executed by either inheriting the return value from the main SQL and then checking to see if a corresponding value exists in the subquery table, or by executing the subquery first and then deliver the main query value. In actual cases of performance issues associated with using subquery have been most commonly in the pattern 2 format. The subquery operation method can be largely divided into filter operation method and join operation method. Depending on which operation method is used, it will have a great effect on the SQL performance. Therefore, it is important that you understand and know how to control the operation method. Filter operation method is a method in which the subquery is repeatedly executed as many times as the number of rows retrieved from the main SQL. For example, if the main SQL returns 1 million rows, then the subquery will be executed 1 million times at most. If the subquery executes 1 million times full table scan, then it can result in serious performance issues. On the other hand, when there is only a few rows retrieved from the main SQL, then the filter operation method may be very effective. However, even when there are many rows retrieved from the main SQL, if the input values are the same or only a few types, then filter optimization is used to increase effectiveness. In filter operation method, the main SQL is always executed first, and the subquery is executed upon receiving the values retrieved from the main SQL. And hence the filter operation always adheres to only one operation order. The filter operation method is not always poor in the performance. This method is favorable when the main SQL returns only a few rows or only a few value types. Let's do 3 tests to verify how the performance in filter operation can change according to the number of rows and the input value types returned by main SQL. The first test is used when the main SQL returns huge numbers of rows and the input values are unique. You can see the filter operation in the execution plan. The trace results indicate that the main SQL has returned 380,000 rows, and because filter operation method was used, the subquery was repeatedly executed 380,000 times. As a result, the majority of the total amount of I/O is generated by repeated index scan used in the subquery. The second test is used when the main SQL returns only a few number of rows and the input value is unique. The filter operation method is used. However, since the main SQL returns only 5 rows, therefore the subquery is executed only 5 times and hence the performance is very satisfactory. The third test is used when the main SQL returns huge number of rows, but there are 26 types of input values. According to the trace results, the main returns 380,000 rows. However, the subquery is not executed as many as the main SQL results row numbers. That is because when the subquery's input value is cached, and in case the input values are the same, the subquery is not executed. Therefore, the subquery's execution count is only as many as the types of input value, which is 26, and so we know that the performance is great. The main factors which determine the file-lerp operation performance are the row number and the input value types returned by main SQL. To summarize the characteristics of the filter operation method, the main SQL is always executed first. The subquery is executed as many times as the maximum number of rows returned by the main SQL. If the row numbers returned by the main SQL is small, then the filter operation method can be very effective. If the input value is unique, then the subquery is executed only as many times as the number of rows returned by the main SQL. If the input value has only a few value types, then the subquery is executed only as many times as the number of value types. The filter operation method always executes the main SQL first, and the subquery is executed when the value is returned by the main SQL. As we have seen here, the filter operation always adheres to only execution order, and hence it is not flexible to adapt to various situations. When comparing between the join operation method and the filter operation method, the biggest difference is flexibility. The join operation method is able to choose what is most favorable from a variety of join methods, including nested loops join, hash join, anti-join, and so on, and even choose the execution order so as to flexibly adapt to various situations. However, join operation method does not have the same benefits from the effects of filter operation method. Therefore, if the number of input value type is small, then filter operation method could be more favorable in terms of performance quality. The test SQL below has been executed with the filter operation method and is generating performance issues. We will determine where the problems exist and see how the performance may be affected when the SQL is induced to execute by join operation method. Because there is no index in column C6 of table T1, the subquery T1 table is being repetitively scanned 221 times, as many as the number of rows returned by main SQL. The performance can be improved by creating an index for the column C6 of subquery T1. However, in actual production environment, creating an index is a big task as it involves many costs, requiring risk and conditions as well. Furthermore, if the newly created index is not used very often, its effects will be very low and hence, you must look for a way to improve performance without creating an index. The most important thing in improving the test SQL's performance is to reduce the number of full table scans. We should change the subquery to execute with join operation method and induce a hash join semi-execution. Hint unnes hash semi-join was granted, and the subquery's execution plan was changed from filter operation method to join operation method, and executed with hash join semi. In this way, it has been modified to execute with only one full table scan. In the initial SQL before the modification, although the absence of an index was the fundamental cause of ineffectiveness, however, in case creating an index is not applicable, we can still make significant improvements just by changing the subquery's operation method.